Hi guys, this is our raw sugar factory steam balance program. All of the calculations in this program is based from Appendix G of sugarcane boiling house manual. Okay, for this specific example, the data used are from the recommended ranges from Yugo and some are from practicum manuscripts. So let's start. For our first tab, you can see the steam generation conditions where we will input the milling rate, operating time, live steam total heat, etc. etc. Okay, so let's start. Okay, so after we have inputted all the necessary conditions, the live steam consumption Q is automatically calculated and shown in this text box. So now we can move on to the live steam requiring components, the cane knives, turbines, shredders, and mill drive. So since we don't know how many cane knives we will need, we can specify up to 3 cane knives in this program. So if we select the radio button 3 text box will appear where we can input the data. So for our cane knives, okay, same is true for turbines. Since we initially don't know how many turbines we will need, we can input as much as 6 data for turbines. So for this specific example, we will use just 4. And for the shredders, we will use 2. And finally, mill drives. So after inputting all the data, we can calculate for the total live steam requirement shown in this text box. Okay, now, sorry, feeder is just 500. Okay, now we can move on to the boiling house. In the boiling house, we can specify the number of effects that we will use, if it is quadruple effect or quintuple effect. Okay, so for quadruple effect, there we can have as much as 4 vessels up to vapor 4. And quintuple effect, we have 5 vessels and 5 vapors. So for this specific example, we will just use quadruple effect evaporation. Okay, and if we compute, the pressure drop per vessel is shown, and also the pressure of the resulting vapors. Okay, one limitation of this program is that it cannot interpolate from the saturated steam table. So we have to manually input the temperature and latent heat values. So the notepad on the right is the summary of all the temperature and latent heat values that we will need for this specific example. Okay, after that, we can check for our configuration by drawing. So if we click draw, there you can see our 4 effect evaporator with the entering steam pressure and the leaving vapor pressures and temperature. We can also do this for quintuple effect, so let's try. Draw. Okay. So let's set it back to quadruple effect and move on to the heaters. For our heaters, we specified up to tertiary heating. And we can select from this drop-down menu the heating medium that we will use. Okay, for primary heater, let's use vapor 2 for example. And if we input the mixed juice bricks, the mixed juice CP is automatically calculated. Okay. And then after we input all the necessary data required, the required vapor will automatically be displayed in this text box. Okay. Okay, so what happens if we use a heating medium that is below the temperature margin as prescribed by Hugo? So for example, in our tertiary heater, what if we use vapor 3? Okay, a message box will appear saying that the temperature margin is below minimum and that we should select another heating medium. Okay, so let's set this back to exhaust steam and move on to pan boilers. Okay, so the total requirement for pan boiler is already calculated since we have specified the milling rate. So now we will just compute for the evaporators. So this first part is the exhaust steam required to raise the temperature of the juice to boiling. And the next is to calculate for the total amount of water evaporated. Okay. We can also calculate for the water evaporated from each effect. There, okay, you can see the water evaporated in the first vessel. Okay, so now let's move on to the steam requirement, where we can see the boiling house requirement here, summarized. Compute the exhaust steam available for process and the boiling house exhaust steam requirement. And since the available steam for process is greater than our requirement, no makeup is needed. Okay. So for a specific steam requirement and bagasse consumption, you can see here the required parameters such as NCV of bagasse, the sensible heat loss in flue gas, milling rate. So no value is still displayed here because we haven't calculated it. And we have to input the boiler feed water enthalpy and the superheated steam enthalpy first. So if we input this and press compute, okay, there you can see that we have calculated for the NCV, the sensible heat loss, the milling rate, specific steam requirement, and the bagasse consumption. Okay, so basically that's it. That's how we use our raw sugar factory steam balance program. So thank you for viewing this video.